In this video, we're going to talk about monopoly, and this is the last market structure. We've already talked about perfect competition, monopolistic competition, and oligopoly. And now we're going to finish with a discussion of monopoly. Again, this is out of chapter 15. Tuesday we'll review, and Wednesday is the final exam. It's officially at 8 o'clock, but there will be an option to start a little bit earlier at 7, and I'll have more to say about that in Tuesday's class. Okay, so let's get started. I'm going to go a little bit faster than I would normally in class, and that's because you have the ability to pause, to write things down, to go back and listen again to what I've said. So just in the sake of efficiency, I'm going to go a little bit faster. So monopoly is a situation where there's one seller and no close substitutes. Also, there are high entry barriers, so it's difficult to get into the industry for some reason. This is similar to oligopoly, where there were high entry barriers. So we don't find too many pure monopolies today. Some examples that come close might be electricity provision, natural gas, water, garbage, what we think of as utilities. And then also patent holders. A drug company might have a patent on a drug for which there is no substitute, and so it would have a natural type of monopoly power. And then we also have historical monopolies like Microsoft. These are companies that have had 80 to 90% plus market share in their respective industries. So Microsoft in desktop operating systems, Standard Oil in refining back in the 1800s and early 1900s, De Beers in diamond production. And then we might find local monopolies. Many of you may have grown up in small towns where there was one doctor, one grocery store. And so there can be local monopolies, depending on the situation and the extent of competition. Although we don't see monopolies per se very often, we still know that the model can be used to really describe a lot of different scenarios where a firm has a dominant market share. So there might be some competition, but as long as the firm has dominance, then the monopoly model is pretty powerful. All right, so let's begin with the model, and we're going to look at a drug company that's got a patent on a particular drug. So we have a downward sloping demand. The demand is less elastic than we would find in, say, monopolistic competition. And then we have a marginal revenue curve that is twice as steep as demand with the same intercept. Now, this is the same kind of setup that we had in a monopolistically competitive firm, right? We had a firm that is able to set the price, and so marginal revenue is always below demand when firms can set the price. And then, so the first thing we want to do here is, as we add in marginal cost and average total cost, is to examine the profit maximizing rule. This is on the upper right-hand side. Just like in monopolistic competition, firms maximize profits where MR equals MC for the very last unit produced. This squeezes out all the profits that we can get from the sale of this drug. So as we look at the graph, notice that MR and MC intersect at the quantity of 100. So we say QM, the quantity is 100. That's what maximizes profit. And then we charge the highest price that we can for which 100 units are purchased. So we draw a line up from QM to the demand curve, and then draw a line over from the demand curve, and that's the price of 40. The last thing we want to do is look at the profit earned by the monopolist. And so profit is price minus average total cost, in parentheses there, times Q. You can see it on the right-hand side. We've calculated it here. And notice here the way that we find that last term, average total cost, is by taking our profit maximizing quantity of 100, and we follow that up to the average total cost curve and then draw a line over, and the ATC here is 30. So the profit is 40 minus 30 times 100, or $1,000. We can see in green the area of profit. We also know that monopolists are inefficient. So we begin here with the demand and marginal revenue curves, and then we put an upward sloping marginal cost curve that is linear, just to make the areas easy to identify. And then we don't have the average total cost curve in here. So we're just going to use marginal cost, marginal revenue, and demand. Note here that when we have a monopoly, the quantity produced is 100. That's where MR equals MC. And we follow that up to the demand curve, and the price is 40. Under that scenario, notice that A is the consumer surplus area, the area below demand and above the price. Producer surplus is all of the areas below price of 40 and above the marginal cost curve. So that's B, C, and D. As we compare that to the perfectly competitive outcome, we're going to find out that the total surplus, the green plus the orange, is smaller than the surplus under perfect competition. In other words, it's not as high as it potentially could be. And we can see this by determining where the perfectly competitive price and quantity would lie if this were instead a competitive industry. So a competitive industry, maybe the drug patent has run out and now you have generic competition. We would find that the intersection of marginal cost and demand dictates the price and quantity. Because remember, marginal cost is the same as the supply curve in perfect competition. So I've drawn a PC dot at the intersection of MC and D. That's to denote the perfectly competitive outcome. So price is 30 in perfect competition and the quantity is 200. Notice also that consumer surplus is ABE in perfect competition, producer CDF. Okay. And then we add those up, we get A, B, C, D, E, F. And when we compare that to monopoly, A, B, C, D, we notice that E and F is missing. And that's the deadweight loss from monopoly power. So we can think about this in the following way. Let's suppose I'm willing to pay $38 maximum for the drug. So you can see that little arrow by the M on the demand curve. I might be sitting there as a consumer, willing to pay 38. That's the height of demand. There's a producer who is willing to sell me the drug for as little as maybe $22. That person or that firm sits where the arrow is pointing just below the marginal cost line. So it's pointing to a point on the marginal cost. So they might be sitting there. And so we could come to an agreement if the buyer willing to pay 38 meets the seller willing to accept as little as 22. They agree to exchange it for something in between, maybe 30. That contract does not take place because the monopolist has set a price of 40. They don't want to drop the price, even though that could generate gains to both buyer and seller. The reason the buyer doesn't, or the seller doesn't want to drop the price to sell me that unit is because they would have to price to multiple consumers. So what are the social costs of monopoly? One of them is deadweight loss. But there are a couple of others. Another one is productive inefficiency. It might be that they are not minimizing cost. The reason monopolists typically don't minimize cost is because there's no one disciplining them, nipping at their heels, so to speak, to keep them at a very low cost efficient level. Okay, so we might find productive inefficiency. And then third, there's another social cost, and that's called rent seeking. This is the use of profits to insulate monopoly power. And so rent seeking would be excessive advertising, excessive number of stores for what you're selling. It could also be the hiring of lobbyists to negotiate with lawmakers better rules that favors your company. So these are all expenditures designed to insulate the monopoly power. Good example of this is sometimes you'll find, for instance, a group of sellers that get together and they lobby for higher safety standards. So one way we see this is in ride sharing. So in the city of Austin, there was a movement to make sure or to pass a law that prohibited any ride-sharing company to operate unless they engaged in background checks for all of their drivers. And so this kind of policy or this kind of law does serve to benefit consumers in terms of safety, but also has the effect of reducing the number of companies that will operate. All right, so what are some solutions to the monopoly problem? Let's take a look. Notice that we have one example of a monopoly is called a natural monopoly. And this is a particular kind of monopoly where we have, for instance, in electricity, very high startup costs. Look at the right-hand side, high startup costs, wiring, power plant. So if that's true, the more electricity you sell, the lower is that average cost per unit, because you're able to spread out those very high startup costs over more and more units. In fact, the natural monopoly is one in which the average cost is falling over the entire range of demand. You see that circled on the top right. And so there are tremendous scale economies in this industry. And that means it would be less expensive for one company to provide the entire market demand than to have competition, because competition means you have multiple very high startup cost investments, and then the companies that compete would have to split the market demand, so they don't get to spread those costs out over many units. So the most efficient market structure is monopoly. All right, so let's begin with this downward sloping ATC and demand cutting through both ATC and a constant marginal cost. Now there are two options, okay, if we're going to regulate this company. And by the way, what usually happens is that a local municipality, a city, will sign a contract with Austin Energy or New Braunfels Utilities that allows those companies to have a monopoly. But in return, they have to agree to be regulated in the price they charge. So we'll see here that the choice for the regulators are two. One, on the left-hand side, you can see we're going to force them to charge a price equal to marginal cost. That's one option. So on the graph, if price equals marginal cost, then you follow that P equals MC to the right, and you hit the demand curve, and so Q units are purchased. The problem is that when we figure profit, we follow Q up to ATC, and ATC is higher than price. So they're negative economic profits. So firms won't get started because they can't find investors willing to invest in their company. So that's not going to work. We do get efficiency, however, in that case. So no deadweight loss. The better option, though, the second best ideal option is number two, where we price at average total cost of the company. So we force the company to price their product at average total cost. So that would be where ATC prime is equal to P prime on the graph. So we find that intersection of demand and average total cost, and that's the price that we force the firm to charge. Under that scenario, the quantity is Q prime, and the profit is zero, because price and ATC are the same. So the firm is earning normal profit, which is good. They do want to operate. The downside of that is that it is inefficient. There is technically deadweight loss here. If you take a look at that orange triangle, that's the deadweight loss, because demand is still above marginal cost for those units beyond Q prime. Okay, but that's the trade-off that we take in these situations. Part of the problem with these regulatory actions is that there's very little incentive to find lower cost ways of making the product. And the reason for that, of course, is because the price is always set at average cost. So why lower average cost when the price is always equal to average cost? So these and other issues abound with price regulation. It's certainly not perfect. In the next video, we'll take a look at antitrust.